Hello and welcome back. I have a question on specific capacity which says tap supplies water at 25 degrees centigrade while another supplies water at 75 degrees centigrade. Now, if a man wishes to bath with water at 40 degrees centigrade, we should find the ratio of the mass of cold water to the mass of hot water required. Alright, so we're talking about cold water and hot water here. So there is going to be temperature change from the cold water. The temperature changes from 25 degrees centigrade to 40 degrees centigrade. For hot water, we should expect that 40 degrees centigrade to 75, but no, it loses. So it's from 75 degrees centigrade back to 40 degrees centigrade, right? So if we remember our formula for heat capacity, right, the specific capacity, which is MC change in theta, then we should note that the heat gained by this cold water, heat gained by cold water must be equal to the quantity of heat lost by what? By hot water. Alright, so if that's that, now we should also recall that for this formula, specific capacity is not given in the question, so we can ignore it, right? So for heat gained by cold water, we'll now have M change in theta. So, and this one too will have M change in theta. So the mass here is what we are going to be looking for. So if we call this one M1 and this one M2, then we can now have M1. Now what is the change in temperature here? We have 40 minus what? 25 degrees, right? And what is the change in temperature here? We'll have what? 75 minus 40, right? So M1 will be what? 40 minus 25 will give you 15. And M2, 75 minus 40 will give you what? 35. So let's see, we are looking for the ratio of what? Mass of cold water to the mass of hot water, right? So this is mass of cold water to the mass of hot water. So we are going to divide both sides by mass of what? Hot water. So if we divide both sides by mass of hot water, we should be having this. So this will take off this, right? So now, so we have M1 over M2 is equals to, if we want to eliminate this 15 from here, so it will be 35 divided by what? 15, right? Okay, so we can break this down as well, because I can see 5 can go into these numbers. So 5 here is what? 7, and 5 here is what? 3. So if we are representing this as the ratio, it will be M1 is to what? M2, or M1 ratio M2. So it's going to give you what? 7 ratio what? 3. That's the final answer. So if we are looking for the ratio of the mass of cold water to the mass of hot water required by the man, so it will be this: 7 ratio 3. All right, thank you for following through in this question. I'll see you in the next video. Bye for now.